Low Earth orbit satellites are creating global business opportunities. Tech giants like SpaceX and Amazon are accelerating their entry into the space market, and Taiwan has formed a national space team. What tests must products pass to enter the space supply chain? Hey everyone, welcome back to iST channel. I'm your host today, Livia. To receive the latest news and professional insights about the semiconductor industry, make sure to subscribe so you won't miss any of our videos. Satellites are categorized by orbital height into low, medium, and geostationary orbits. The most popular LEO communication satellites have recently become commercialized, providing seamless connectivity, with SpaceX ushering in a new era of space economy. Satellites contain many familiar electronic components like memory, processors, and power management chips. Space-grade components are expensive and may face export restrictions. COTS components, used in devices like smartphones, computers, and cars, are affordable and readily available. Because the space environment in LEO is less harsh, using COTS components for space missions has become a trend. However, since the ground and space environments differ, these components must pass several tests before being used in space. The first test is the vibration test. During a rocket launch, the rocket experiences severe vibrations. The vibration test ensures that the satellite and its components can operate normally after the launch. The second test is the acoustic test. Rocket launches also generate acoustic noise. Large and thin parts, like solar panels or antenna panels, are particularly susceptible to acoustic vibrations, which can cause cracks or malfunctions. An acoustic chamber simulates this noise to ensure component quality. The third test is the shock test. As the rocket reaches a certain altitude, the engines and fairing separate, releasing the satellite into orbit. These processes create shocks that are challenging for the solder joints and chips. The shock test on the ground assesses the satellites and components' tolerance to these impacts. The fourth test is the electromagnetic compatibility test. Satellites contain various electronic components and may share space with multiple satellites in the rocket. Electromagnetic interference between satellites and the rocket is possible, so an EMC test ensures they won't interfere with each other. The tests mentioned so far cover the rocket launch environment. Once in orbit, satellites face the unfamiliar space environment with extreme pressure and temperature differences from Earth. Ensuring components function properly in these conditions is crucial. We have invited Dawn, an expert in space environmental testing from iST, to explain how to simulate the space environment and conduct tests to ensure component reliability.
Hi everyone, I'm Dawn. Since the launch of the first artificial satellite in 1957, 60 years later, there are nearly 10,000 satellites orbiting the Earth today. LEO communication satellites can provide global coverage and have applications in communication, weather, navigation, and more. They can eliminate communication dead zones and ensure national security during wars and natural disasters. As previously mentioned, rockets transport satellites into space. Once a LEO satellite reaches its orbit, it travels at a high speed of 7 kilometers per second, completing an orbit around Earth in approximately 90 minutes. In space, satellites are exposed to a vacuum and face extreme temperature fluctuations due to solar radiation. Without the protection of Earth's atmosphere and magnetic field, satellites and their electronic components are subjected to intense radiation. Therefore, we simulate space conditions on the ground through tests such as thermal vacuum cycling and radiation tests to ensure that satellites and electronic components can function properly in space. When a satellite is exposed to direct sunlight, its temperature can reach up to 120 degrees Celsius. Conversely, when it moves away from the sun and is shaded by Earth, the temperature can drop to minus 120 degrees Celsius. Thus, as a satellite orbits Earth, it undergoes significant temperature cycles. Additionally, in a vacuum, the lack of air particles can cause electronic components to overheat and fail due to poor heat dissipation. The vacuum environment can lead to material decomposition or outgassing, which generates contaminants. For instance, contamination of optical lenses can degrade image quality. The thermal vacuum cycling test simulates the vacuum and temperature variations of space. During this test, the satellite or electronic components are placed in a low-pressure vacuum chamber. The equipment then simulates solar radiation by heating and cooling the components through radiation and conduction. Due to the extreme temperature differences in space, satellites have thermal control systems to keep electronic components within an operational temperature range. The thermal vacuum cycling test also evaluates the functionality of these thermal control systems. Earth's atmosphere and magnetic field protect us from radiation, but in space, satellites and electronic components face direct exposure to radiation. The primary sources of space radiation are charged particles such as electrons, protons, and a few heavy ions. If these particles strike satellite electronics, they can cause leakage, data corruption, malfunctions, or even permanent failures. Usually, a malfunction can be resolved by rebooting the system, but permanent failures can lead to the loss of communication or control of the satellite. Radiation tests estimate the frequency of in-orbit malfunctions and help identify unsuitable components for replacement or improvement. After passing all of the aforementioned tests, the final crucial step is obtaining flight heritage. This means launching the product into space and completing various missions such as communication, imaging, and navigation. The more successful missions a product completes, the higher its value becomes. In the space industry, flight heritage is highly regarded as the best certification for space products.
Since joining the Space Radiation Testing Alliance in 2021, iST has completed numerous radiation tests on electronic components and continues to develop comprehensive one-stop space environment verification services, helping clients focus on product design and manufacturing. For more detailed articles, please click the link in the comment section. If you have any topics you'd like to see, feel free to leave a comment. If you have any questions, you can email us or join our official Line account. To stay updated with the latest news, follow us on LinkedIn or Facebook. That's a wrap for today. See you. If you enjoyed our video, don't forget to like, subscribe, and hit the notification bell so you won't miss any updates.